Hey everyone. In business intelligence, it often feels like we're drowning in data, but absolutely starving for real insights. So today, we're going to talk about how to turn all that chaos into clarity. We're going to dive into a skill that makes it all possible, something called data modeling. Let's get into it.
So here's the problem we all run into, right? You've got your sales data in one place, your product information in another, and maybe your employee details somewhere else entirely. They're all like these separate little islands of information. How in the world do you build bridges between them so you can actually see the whole picture?
All right, to make this all feel a bit more real, let's invent a company. We'll call them Awesome Chocolates. Now, they've got data on all their shipments, their products, their salespeople, but it's all split up into different files. This is a super common setup. I'm sure many of you are nodding your heads right now. Okay, so here's our game plan. First, we'll look at this data puzzle. Then we'll define the building blocks, facts, and dimensions. After that, we're going to build something called a star schema. See why it's so powerful? And wrap up with why modeling is, without a doubt, the foundation of all BI. So let's start with the puzzle itself. In the real world, you almost never find all your data in one gigantic, tidy table. That's not how it works. For Awesome Chocolates, their data is broken up pretty logically. We've got a shipments table. That's where all the transactions get recorded. Then there are these other tables that describe stuff. The products, the people who sell them, the locations they're sold in, and even a calendar table to keep our dates straight. Each one holds a really important piece of the story. But here's the catch. If you look inside that main shipments table, all you see are a bunch of IDs. You see a shipment happened, but it just says product ID 5, salesperson ID 12, and location ID 8. It tells you that something happened, but it doesn't tell you what chocolate was sold or who sold it or where it went. It's a list of events, not a book of answers.
So, how do we solve this?
Well, we start by understanding the two basic types of tables we're dealing with: facts and dimensions. These are literally the building blocks for our entire data model. First up, we have the fact table. The easiest way to think about this is that it's the table that records actions. It's the events, the transactions. For us, the shipments table is our fact table. It's tracking every single shipment, how many boxes were sent, how much money was made. It's just full of numbers and, crucially, those keys that are going to link out to our other tables. And the other type of building block? Those are our dimension tables. These are the descriptive tables. They give us all the context: the who, the what, the where, and the when. Our products table, our people table, they're all dimensions. They're what turn an anonymous product ID 5 into Manuka Honey Choco. They give our data meaning. Now, here's a really cool way to remember the difference. Think about their shape. Fact tables are usually tall and narrow. Why? Because they can have millions, even billions of rows of transactions, but maybe only a handful of columns. On the flip side, dimension tables are short and fat. Awesome Chocolates might only have, say, 22 products, so not many rows, but each row could have tons of columns describing that product in rich detail. Tall and narrow, short and fat. Okay, so we've got our building blocks. Now it's time to look at the blueprint. Let's see how we put these together into this really elegant and incredibly powerful structure called the star schema. At the very heart of our model, the sun in our little data solar system is the shipments table. It's our fact table. Everything else is going to revolve around it because it's the table that records the events we actually want to analyze. So the key to this whole thing is how these tables connect, and the relationship is what we call many to one. Just think about it for a second. You can have many different shipments of one specific product, right? So the many side of that relationship lives on the fact table, and the one side lives on the dimension table. It's that simple. And here's what that looks like. We have our central shipments table, and it's connected to each one of our dimension tables. Many shipments connect to one product. Many shipments are handled by one salesperson. You see? It creates this classic hub and spoke design. And this beautiful structure has a name. It's called the star schema. You've got the fact table in the middle, and the dimension tables radiate out from it like the points of a star. Or, as the source material funnily points out, it also kind of looks like an octopus. Whichever visual helps you remember, this is the absolute gold standard for this kind of work. All right, so we've built this elegant thing. But why? What's the big deal? What's the payoff? This is where we get to see the real magic happen. You see, the power isn't really in the tables themselves. It's in the connections between them.
These connections enable something called filter propagation. It sounds technical, I know, but the idea is actually super simple and incredibly powerful. It just means that a filter you apply to one table can automatically travel along these connections and filter everything else.
Let's just walk through it. Imagine a user clicks on New Zealand in a filter on their report. Instantly, the locations table is filtered down to just that one country. Then, because of our connection, that filter propagates. It travels down the wire to the shipments table, which immediately throws out any shipment that didn't go to New Zealand. And just like that, every single chart, every KPI, every number in the report updates in a flash.
Okay, so take a look here. This is a chart of our sales before we apply any filters. This is the global view, all countries combined, and it looks like peanut butter cubes are our #1 seller.
And now, boom, we click that New Zealand filter and look what happens. The entire chart just transforms before our eyes. Suddenly, Manuka Honey Choco is the runaway winner, and the sales numbers are specific only to that one country. That is filter propagation in action. That is why we build the model. It makes our data come alive.
So let's zoom out for a second and look at the big picture. Why did we spend all this time carefully connecting these tables? Well, it's because this process, it's the bedrock. It's the foundation for everything that comes after. Data modeling is what makes those slick, interactive reports even possible. It's how you take messy, disconnected data and forge it into a single source of truth that everyone can trust. It is, and I'm not exaggerating, the heart of any business intelligence system. And you have to understand this. If your model is wrong, then every single chart, every single analysis you build on top of it will also be wrong. Period.
So I want you to think of it this way. Data modeling is not just some boring technical chore you have to get through. It's the process of building the intelligent brain behind your analysis. It's what gives your data the power to answer complicated questions in an instant. And that really just leaves us with one final thought. Every single data set has a story locked inside of it, just waiting to get out. So the question you need to ask yourself is this: is your model built to tell that story?